know, something like that, s plus 1, something like that, right? Else, failure, count it as a failure state. And then, what do you do after the for loop? You can have success divided by 100, failure divided by 100. That gives you the success probability and failure probability, right? That is the idea of the random sampling. Does that make sense? First thing, you need to construct this table. By constructing this table, I mean giving the conditions. Draw random numbers and match these conditions. It has only 2 conditions. If random numbers come out to be a certain value, then you choose that value. You choose that state. You don't need to use the for loop or do the condition like I do. It's up to you, okay? But the concept, I think looks something like this. You still look worried, you ask, okay? We have time. Just ask. Which one is not clear? First, do you understand the part of the random numbers? Can you draw random numbers from the software? What software are you using? MATLAB? Oh, MATLAB is RAND. RAND. Right? It's RAND. And then you choose like, you know, maybe you can just ask RAND and then you assign, maybe you say that this is a random number for the generator, you call it RG, and then you have a random number for transmission line. When you do coding, it's important to name the variable in the way that you can read so that you don't get confused. But the bad thing about it is that if you assign too long of the variable, you might have some syntax error. But in this case, it's a very short code. So write whatever you find makes sense, like Rn for gen. If I were to write, I would say Rn for gen, and then Rn for T1, Rn for T2, and then I assign this random number to it. And you know that these random numbers are numbers between 0 and 1, right? That has equal chance of happening. Equal chance of happening. So when we are trying to draw samples out from this, essentially we're saying that our cumulative probability looks like this. The chance of it getting to be 0 megawatts is slimmer than the chance of it going to be 100 megawatts. This is 0 megawatt, this is 100 megawatts, right? Makes sense? So when you assign the range of the random values to be higher, meaning that the chances that you draw, it's likely to be 100 more, right? So it will take out the states, that is 100, more often than taking out the states of 0. So I would imagine that for 100 states, you would have a very small values for the failure state, because it's not likely to sample it out. But all these, it's random. You don't really know. When you estimate 100 and 200 and 1000, you see that it will get closer to the actual values. Okay, so now you write the when I think when I taught this, I would have one lecture on tutorial for MATLAB. If I recall, that was like long time ago. I asked my PhD student to conduct a tutorial for MATLAB so that you get equipped with these tools. But okay, do you understand how you get the random numbers now? So you get the random numbers, and these random numbers are the numbers between 0 and 1. What do we do with these random numbers? We look at if these random numbers fall into which range. Okay, so you have to write a condition. If Rn for G is greater than, let's say you cut this off by 0.01. If it's greater than 0.01, okay, then you say G equals 100. Right? Else G equals 0. Okay, makes sense. Same thing. If Rn for T1 is greater than or equals to 0.1, then T1 is 100. Else T1 equals to 0. Now I'll give you 50. So you got the idea, okay? Look at the syntax as well, and these are very short program. So you write it and you run the loop, okay? So each of the loop, each of the sequence, each of the time you find the sample of the states, you draw 3 random numbers, and then you evaluate by you draw random number, and then you assign the values to these 3 components. And with these 3 components, you look at the condition when the system is success. Okay, and if the system success, then you count. This is counting the states. This is counting that this is success state. And this is counting that it's the failure state. So each time you start, don't forget to let S equals to 0, F equals to 0, okay? Initialize it first. Okay. Writing program these days should be easier, I believe. Right? Okay? Remember, find loss of load probability. Loss of load probability is when you count. Loss of load probability is number of failed states divided by the total sample. Right? Simple. So the failed state is F divided by the total sample. It would be 100 or 500 and 1000. Okay. You can run it consecutively, meaning that you use the solution of 100 as in 500 and 1000. You can do that, or you can run it separately. These are very quick calculation. Doesn't take any time from your computer, so you can just run whichever way. Okay. The part when we do the power system reliability, the most important part will be in this evaluation, system state evaluation. And when we run the power system reliability analysis, we combine it with something else. For example, we wanted to know what is the amount of reserve in the system, what would be the planning, how much capacity we should add in, at which location we should add in. Those becomes an optimization problems. And you use this kind of a reliability index as either a constraint or as an objective function. And it's very time consuming to calculate these system states because it's not like a conditions that you can write, but it's a power flow that you need to run to find whether the system satisfy the constraint, or sometimes you run the optimization problems. Okay, does that make sense? Better?